Today I'm talking about how to graph data using ordered pairs on a graph. We're first going to look at this table that shows Ryan's height at different ages. At age 1, he was 30 inches. At age 2, he was 35 inches, and so on and so forth. So first thing that we're going to do is write down the ordered pairs. Write down this data as ordered pairs. The first ordered pair is 130. And the next one is 235. The next one is 338. Next is 441. And finally 544. So we can, I know that the age goes first because it's the x-axis. So that's why we have age and then height in our ordered pair instead of the other way around. So let's graph these. The first one is 130, so over 1, up 30. Next, we have 235, over 2, up 35. 35 is between 30 and 40. And next we have 338. Now that's almost a 40, but not quite. Next we have 441. That's a little bit more than 40. And finally we have 544, which is a little bit less than 45. And you can see there's an upward trend here for Ryan's height. It's a little bit of a curve. It will eventually level out as he stops growing. And that's a very useful way to display information. Next, we have a table that says plant height. Now, you'll notice that the numbers on the side here, they go by 4s. That means that each square is going to go by 2s. So this one here is going to be 2. This one's going to be 6. And so if we want odd numbers, we need to go in between them. So it's very important that you understand the scale of your graph. This one goes by 5s, a little easier to understand. This one goes by 2s. So we're going to write down the ordered pairs for the plant height. The first ordered pair, again, day is the number of days is on the x-axis, so it's going to be first, and the height of the plant is going to be the y-coordinate. So our first ordered pair is 5-1. The next one is 10-3. The next one is 15-8. Then we have 2012, and I'm running out of room, so I'll put it here. 2516 is the last ordered pair, and then we graph them. So the first one is 5-1. So 5-1, it's going to be over 5, up 1. Now if I go up to that first line, that's going to be a 2. So I want 1, so that's halfway between 0 and 2. So a lot of students did either this or this, and that is wrong. You have to be very careful that you understand your scale. The next one is 10-3. Now 3 is going to be halfway between 2 and 4. It's going to be right there. Some students felt like they had to line up with the line, and that is incorrect. That would have given us 10-2 or 10-6. The next one is 15-8. The next one is 2012. Those are easier. And then we have 2516. You can see kind of an upward curve here for the plant height as it's growing. Now, this is a very useful way to show data. You may see this a lot in science class and in science projects. It's much more useful than just looking at a list of numbers. It tells us what's happening in the situation or in the experiment. So I'm going to go over a common error that students make that will give you a completely different graph than what you should see. I'll read the problem. Mary places a miniature car into a track with launchers. The speed of the car is recorded every foot. Some of the data is shown on the table. Mary graphs the data in the coordinate grid below. So let's take a look at the ordered pairs here. So she's launching this car, and at distance 0, she's going at 0 miles per hour. And then at a distance of, and the distance is going to be at the x-coordinate because it's on the x-axis. Then we have a distance of, at distance 1 foot, we have 4 miles an hour, so that's 1/4. At a distance of 2 feet, it's going 8 miles an hour. At a distance of 3 feet, it's going 6 miles an hour. 4 feet and 3 miles per hour. So let's see if her graph matches that. So the first point is 0, 0. And we can see that 0, 0 is correct, so that point is correct. Our next point that she graphed is 3, 4. Now, if we look over to our ordered pairs, there's no 3, 4 there. So this is incorrect. The next one she graphed was 4, 1. And if we look over here, there's no 4, 1 either, so that one is also wrong. Next, we see we have 6, 1, or 6, 3. There is no 6, 3 either, so that one is wrong. And then we have 0, 8, or excuse me, 8, 0, 8, 2, excuse me, 8, 2. And there's no 8, 2 either. But if you look at what we have, the numbers that we are supposed to graph and what she graphed, you'll notice that there is a similarity. She's using the same numbers, but she flipped X and Y. So she got completely wrong data points because she graphed the Y coordinate first and the X coordinate next. So what I'm going to do is I'm going to graph the correct data on top of the incorrect data, and then you'll be able to see how different they are and how much this can ruin your graph and give you false data if you flip the X and Y. So our first point is 0, 0. Well, if you flip that one, you'll still get 0, 0. So that's why she didn't mess up 0, 0. So that one is correct. Our next point is 2, 8, which is, or 1, 4, right there, and then 2, 8, and then 3, 6, and then 4, 3. And you can see how different this is than what she graphed. Her car goes fast after being launched and then slows down from friction. That makes sense. Now, what she graphed is a car speeding up, slowing down, speeding up again somehow, and then slowing down again, and never going very fast. That is incorrect. That is not what is representative of the data. So that shows you why you cannot mix X and